Have you ever just stopped and wondered about the magic happening behind your screen? I mean, we click and tap on things all day long, but what's really going on in the background? Well, in this explainer, we're going to follow the incredible journey of just one single click to see what's actually happening.
It seems so simple, right? You hit play, the video starts. But in that tiny fraction of a second, your request kicks off this epic adventure across the entire planet and back again. So let's trace that path, step by step.
Okay, but before our click can even leave the station, we need to understand the world it travels through, and that is the world of computer networks. Think of it as the highway system for all of our digital information.
Now I know, that sounds super technical, kind of like something straight out of a textbook. But all it's really saying is that a network is just a bunch of devices that have all agreed to talk to each other and, share stuff.
So if you boil it all down, a network is really just three simple things. You've got the devices themselves, your phone, a big YouTube server, whatever. You've got the connections that link them up, like your Wi-Fi or those massive undersea cables. And then you've got the whole reason for the network in the first place, the shared resources, which in our case is the video you want to watch.
And this really shows you why networks were such a game changer. Remember having to physically move data around on floppy disks, then burning CDs, then USB drives? What a hassle. Networks let us share anything instantly from anywhere in the world without getting up.
All right, so the stage is set. Our click is ready to go. The very first thing your computer has to do when you ask for a video on YouTube.com is figure out where in the world is YouTube.com.
And here's the first hurdle. See, computers don't really get names like we do. YouTube.com is easy for us to remember, but for a machine, it's just nonsense. It needs a specific numerical address to send your request to.
And that is exactly where DNS, the domain name system, comes into play. The absolute best way to think of it is as the internet's giant global phone book. Its one and only job is to look up the name you gave it and find the right number, the IP address, that your computer needs.
This whole little back and forth is called a DNS lookup, and it happens in a flash. Your computer basically yells out, "Hey, does anyone have the number for YouTube.com?" And a DNS server out there instantly yells back with the right IP address.
And just like that, we have our destination address. It's like the coordinates are locked into a GPS. Now, the real journey can finally begin.
So, your request zips across the internet and arrives at the location that the IP address pointed to. But getting to the right building is only half the battle. Now, we gotta find the right door. This whole thing works because of what's called the client-server model. It's actually really simple. Your device is the client, it's asking for something. And that powerful computer at YouTube holding the video? That's the server, and it's there to provide or serve what you ask for. And this is where that apartment building analogy is so perfect. The IP address is like the street address. It got our request to the right building, the YouTube server. But that server is a huge skyscraper doing thousands of things at once. The port number is like the specific apartment number. It tells the server, hey, I'm here for the video streaming service, not for email or anything else. And these numbers aren't random. There are standard, well-known ports for specific things. Port 80 is usually for regular old web pages, but your video stream, oh yeah, it's almost certainly using port 443, which is for secure encrypted traffic. That's the S in HTTPS. Okay, so let's recap. Our request has found the right server and it's knocked on the right door. But how do they actually talk to each other? Well, they need to agree on a set of rules, a common language. In the world of networking, these rules are called protocols. It's a lot like how you and I are communicating right now using the rules of English. Computers use protocols to make sure that data gets sent, received, and understood the right way. So the foundation for all of this is the Internet Protocol, or IP, that handles all the addressing. But layered on top of that, we have HTTPS. That's the specific set of rules that manages the request for the actual video, and maybe most importantly, it makes sure the whole connection is encrypted and safe. So the YouTube server got the request, and now it's sending the video data hurtling back towards you. The data flies across the world, and it makes it to your home router. But how does it make that final jump from the router to your specific screen?
Well, every single device that connects to a network, your phone, your laptop, your smart TV, has a piece of hardware in it called a Network Interface Card, or NIC. You can think of it as the physical gateway that lets all the data in and out of your device.
And this brings us to our final, super important distinction.
The IP address was the global navigator, right? It got the data all the way to your front door, your router. But inside your house, you might have a dozen different devices connected. The MAC address acts like a local mail carrier. It picks up the data from your router and delivers it only to the specific device that actually asked for it.
And this MAC address is a totally unique 48-bit number that's physically burned into the network hardware by the manufacturer. It's like a fingerprint for your device on the local network, and it's what guarantees that video data finds your screen and not your roommate's laptop. And there you have it. From one click, your request used DNS to find an address, knocked on the right port at the server, communicated using protocols, and then the video data was delivered back across the world using an IP address, and finally to your screen with a MAC address. All of that in less time than it takes you to blink. It's wild.
It is an absolutely incredible system that we rely on every single day, and the speed is already just breathtaking. It really makes you stop and think. If this is where we are now, what's the next great leap forward going to look like? What will connection even mean in another decade?